Hello. So what we're going to do is this will be the first of a few videos. First one I'm going to put up here right now is the one that is going to be like the first 6 questions. We're going to call this angles in the unit circle. I had written some titles here. So here's what we're going to do. I'm going to sort of read the questions and then we'll draw them out. So like here, draw the following angles in standard position. Standard position just means I am looking at an angle, starts an XY coordinate plane. That is the vertex. That is my start. So that would be 0 degrees. Now, you guys know degrees and radians, so I'm not concerned about any of that. What I'm mostly trying to look for is, will you be able to draw the rest of them as we go? So like, I'm pretty sure you'll be able to do this, but who knows? So here we got 135 degrees in standard position. That is second quadrant. Its reference angle is 45 degrees. So from here to here, that is 135 degrees. That is the first part of it. Now, negative 60, I'm going to do a different color, maybe. I'm going to do a different color because that's going to be sort of a way of looking at it. When we have a negative rotation, we are, instead of going counterclockwise, we will be going clockwise. So in this case, negative 60 degrees will put us from here down to about there. This will be negative 60 degrees. 7 pi over 6. Let's start with a whole different set of things for that. 7 pi over 6 is going to be, here we go. I'll write it up here. We are looking at an over 6 thing. It is in the, well, it's greater than 1, so it's going to be more than just a single pi. Since this is pi, this will be pi over 2, this will be 3 pi over 2, and this will be 0 or 2 pi. What we'll do for 7 pi over 6 is to recognize that since it is larger than pi, it is going to be pi over 6 more than that. That works out to about 30 degrees. So that'll sit right about there. So from here around to here, this will be our 7 pi over 6 because it is one more than just the pi. With 6 over 6, it would be pi. 7 pi over 6 is that. Now, for the last one, it's 5 pi over 2. So let's see if we can remember this for a second. I know that right over here is 2 pi. So this would be 4 pi over 2. If I want to go 5 pi over 2, that is an additional one, which means I'm adding a second pi over 2 to that, or another pi over 2, which takes us to here. Now, if I'm drawing that in standard position, we're talking about 5 pi over 2, that means I have to show where it started, to recognize that I go one full rotation around like this, and then that's going to come back up and go all the way to here. So our angle will start there and end there for this to be 5 pi over 2. A cute little curly Q as we got that going through there. Again, drawing the angles is important. I think that ultimately the reason why I have 4 here is just so you guys have a place of going, oh, I know how I could draw that. And this is what it's going to look like to go a little bit farther. The next thing that we're going to be doing is working with the unit circle. You will get one of these, so I'm not concerned with your ability to do that. But what I am going to ask for you to do as we start looking at this is to recognize that some of it's not just copying things down, right? So if we're talking about the sine of 5 pi over 6, that's one that's definitely on there. You can find it. It's in the second quadrant, so it's going to be positive. And if it's the sine of 5 pi over 6, we are looking at a positive 1/2 for that one. Cosine of negative pi over 4, that is going to be in our fourth quadrant because it's a rotation down. It's the cosine. So that is going to be giving us the square root of 2 over 2, and it has to be in positive because that is in the fourth quadrant. Negative 3 pi over 2. Now let's think about that one for a second. Negative 3 pi over 2 is going to take us all the way back up to there. So that is going to be the same as what sine would be at sine of pi over 2, which in this case is going to be a positive 1. 11 pi over 3. Well, let's think about that one for a minute. If we're talking about 2 pi, let's see how many multiples of 2 pi we have. With 3 as a base, that is going to be 6 pi over 3. We would add to that the 5 pi over 3. That would get us 11 pi over 3. So 11 pi over 3 is going to be sitting at the same place that 5 pi over 3 is on our unit circle. So with this, if I am looking for the cosine of that, that will be in our fourth quadrant, so it's going to be positive. And if it's over 3, that means that we are looking at one that is going to be sitting right about there as we're doing it. So this will be the square root of 3 over 2. Now we start to roll into the world of secants and cosecants. This does take a little minute. You're going to be doing some of this stuff down here too as we combine them. But when we talk about something finding the cosecant, we have to remember, what is it the reciprocal of? So the cosecant is the same as 1 over the sine of pi over 6. Does that make sense? I'm glad you're answering because this is a video. So yes, it does make sense. So when we look at that, 1 over the sine of pi over 6 is going to be the same as 1 over, now let's think, pi over 6, the sine is the y value, that is going to be 1/2. Well, 1 divided by 1/2 is the same as 2. So that's going to be the value of the cosecant of pi over 6. Hope we're still good. All right, so coming back up here, secant of 135 degrees. Secant is 1 over the cosine of 135. Now, the cosine of 135 degrees is negative √2 over 2. That means I'm taking the reciprocal. So this is going to be negative 2 over the square root of 2. Now, if we're just doing this and you're like, I don't want to go any farther. Well, shut up. You got to do more. So when we're looking at this, I can't have the denominator as a square root. So I'm going to multiply the top and the bottom by √2, rationalizing it. This will now be negative 2 √2 over 2, or just negative square root of 2. All right, guys. Pretty great, isn't it? Yes. Yes, I know it is. Okay, so the next thing we're going to do, tangent of pi. Now, the tangent is our y value over our x value, our sine over our cosine. At pi, the y value is 0. The x value is -1. So the tangent at pi is going to be 0. All right. The secant, actually, let's do the cotangent one because I think it'll be easier for us to do. Cotangent in this case is going to be x over y because it's the reciprocal of the tangent. So if I'm doing the x over the y at 4 pi over 3, that is in the third quadrant, the 4 pi over 3 is, which means they're both going to be negative. So we will have the x value at 4 pi over 3 is going to be -1/2. The y value at 4 pi over 3 is going to be negative square root of 3 over 2. I'm trying to make sure I'm doing that right in my head. Yep, that is correct. You guys can check it. If I screwed it up, then they're just flipped. We will be canceling out the negatives. And we will say that at the end of this, if I do the reciprocal of this, multiplied times that, I'm going to get 1 over the square root of 3, which we can't keep. So we'll multiply the top and the bottom by √3, and we will end up with square root of 3 on the top, 3 on the bottom, and that is our answer for the cotangent of 4 pi over 3. All right, secant of 240 degrees. God, I didn't leave myself a whole lot of space here. Secant, again, we said from before, is 1 over the cosine. So this will be 1 over the cosine of 240 degrees. Okay, so that is going to be 1 over, now 240 is going to be it's going to be the one that's down here. So it is a 60-degree one that's there. So when we talk about the cosine, this will be a -1/2. 1 over that is -2. Okay. And then if I take the tangent of -7 pi over 6. All right, here's what I would have you do. We're talking about tangent -7 pi over 6. What I'm going to do, because right now I'm doing all this crap up here and it's a pain in the ass, and I don't want to figure out where that's on there. I'm going to do this. If that's a negative rotation, it is going to be in the same place if I add a full rotation to it. So I'm going to add 2 pi to that so I can figure out what that's actually going to be when I look at it. This is just what I do in my brain. So this is the tangent of, well, let's see, 7 pi over 6. That's a negative. And I'm going to add to that 6 pi over 6. 12 pi over 6. Sorry about that. Because that's what a 2 pi with a common denominator is. This is going to be the same as the tangent of 5 pi over 6. That is where it is at on our unit circle. If we look at it, the negative rotation took me to that. Now 5 pi over 6, I do know where that is. That's in the second quadrant. And since the tangent is the y over the x, we're going to be looking at 1/2 over the square root of 3 over 2. We did one of these already, the 1/2 over square root of 3 over 2, where they were both negative. So at the end of this, we are going to get that this is equal to, oh, I'm sorry about that. The x is negative. It will be negative square root of 3 over 3. Damn, that's a lot of talking. But I feel pretty good about how all of that has gone. We did a whole lot in the same space. So here is kind of what my thought process is going to be. I can totally go through what these are going to be with multiplying these things together. And I'm going to in just a second, but I am not going to use the space that we have here to do that. So I'm going to write these problems for 3 on another page for us to be able to do it, because there's just, like, I just killed way too much happening up there. So I think it'll be easier for us to do it kind of up in this space. And the other thing that I'm going to do to save myself some time and brain space, so I'm going to walk over here and get myself a unit circle. One more sneeze coming, I can feel it. Oh. Right. So here we go. With that being said, the unit circle is here in my space, so I can just look at it, which will make life lots easier. Okay, so the cosecant of 2 pi over 3 is going to be 1 over the y value. And the tangent of 7 pi over 6 is going to be the y value over the x value. Now, here's the thing. You see what I've written here. And I know that what you're thinking is you can cancel it. But you notice that this angle and this angle are completely freaking different. And that means that I have to use 2 different values on here. So at 2 pi over 3, the y value is square root of 3 over 2. So this is 1 over the square root of 3 over 2. And I'll work with that in a second. At 7 pi over 6, it's y over the x. So the y is negative square root of 3 over 2. And the x is negative 1/2. Now, I'm going to tell you something that I would do. If you notice, I've filled everything in here. Sometimes things luck out with what we're looking at. For me, what's lucked out is this guy here and this guy here are the same number. This is just negative. So I'm going to cancel these 2 negatives out. Then I'm going to say, well, that and that cancel out because they are the same factor on the top and the bottom of my result. So what I'm going to end up with is 1 over 1/2, which is just equal to 2. So the answer to this one is going to be 2 when I'm done with it. Now, when you do that crap on the test, if you write this and you write a 2, I am not going to give you the credit for that because I want you to use your unit circle, which means you got to fill this crap in. I got to see this work. And if you're not happy about that, well, I look greatly forward to you complaining about the fact that that grade was not what you wanted it to be. And it should be lovely. Why can't we use our calculator? Because, fool, I told you you couldn't. I'm talking to a non-existent human being that is not actually saying that out loud. And I called you a fool. That's right, non-existent human being. Stop being so terrible. Okay, tangent. That's our y over our x. And this is our x over our y. I would love it if these things would match up lovely so I can cross them out. But let's look. At pi over 6, this is going to be 1/2 over square root of 3 over 2. Times at the 11 pi over 6, this is going to be 1/2 negative 1/2 over square root of 3 over 2. Yep. Nope. I flipped them. No, it's x over y. This is where I'm going to call myself a dumbass on screen. Guys, what a dumbass Mr. Bechtel is. Why would he be such a dumbass? Silly dumbassery. Nobody's going to listen to this. Certainly not play it for your parents. Okay, so when I'm looking at what we have right here, I have repeated this in the right way. I just used the x and the y from 11 pi over 6 on here. I use the y and the x from the pi over 6. And if we look, those 2 cancel out. Those 2 cancel out. But this is a negative. So when I'm done with this and I multiply it, it will all be negative 1. Woo! That's equal to negative 1. There we go. The final one. Secant of 5 pi over 4, that is going to be 1 over the x value, minus, it's going to be common denominators here. Cotangent is our x value over our y value. Okay, so let's find these. The secant at 5 pi over 4 is going to be 1 over negative square root of 2 over 2. Minus, hoping we have a common denominator when I do this, but who knows what's going to happen. 2 pi over 3 is right there. And if I put the x on the top, that is going to be negative 1/2 up there. And on the bottom, it is going to be positive root 3 over 2. It looks like I got to do a little bit of work here. For the last one, of course, I have to do the work. So here, this is the reciprocal of it. So this is going to be 2 over the square root of 2, and that's going to be negative. When I take this one here, it is going to be, that minus a negative will be a positive 1 over square root of 3. Now, I would feel compelled to rationalize these denominators by multiplying the top and the bottom by our respective square roots. This now is going to become a 2, which will cancel with that one, and I will have negative root 2 as a result of that. I might as well put it over 1 because I might have a fraction here. Here, I'm going to have the square root of 3 over 3. So if I want a common denominator, well, I got to multiply this one by a 3, so it's over a 3. And now, when I add them together, my denominator will be a 3. I will have negative 3 root 2, and I will be adding to that the square root of 3. These are not common roots, so I can't combine them. This is the simplest form of this that I can get. So the equals for that one is going to be negative 3 root 2 plus the square root of 3 all over 3. I think for the sake of time, I'm going to stop now with this video, and then I'm going to go on and do another one for the next one. So this is going to be problems 1 through 3. So it took a little bit longer than I expected. So for right now, I am going to stop my sharing, and I'm going to stop my recording. See you in a minute.